In this lecture, we're going to begin with an introduction and a general overview of simple correlational analysis. And just touching on some key points here, when we conduct a correlation analysis, the aim here is to examine relationships between variables. And it's important to note, and this will be repeated throughout this unit, that the correlation analysis is not intended to establish cause and effect relationships, but rather just the simple relationship between variables. And in doing so, we change our terminology here somewhat. Typically, when we examine research studies, we identify an outcome variable or a dependent variable. When we conduct a correlational analysis, specifically the dependent variable is referred to as the criterion variable. That's typically the variable of interest among researchers. And with a correlational analysis and eventually moving into a regression analysis, the variable that we plot on the x-axis that we've typically referred to as the independent variable, we now call it a predictor variable. And when we begin the process of conducting a correlational analysis, we very often start with a scatter plot. This is before we actually get into any of the specific mathematics of conducting the statistical analysis. And so the scatter plot, and we'll see a few of those here in the next couple of slides, will give us a sense, a subjective visual observation of whether a relationship potentially exists between two variables. And overall, when we eventually conduct the statistical correlational analysis, we're looking for two things. We're looking for the direction of the relationship and how strong that relationship is between two variables. And in doing so, the correlation analysis will help to indicate the degree of consistency between these two variables of interest. And in doing so, we also examine the variability in the y-scores. So that's typically on an xy plot. That's our criterion variable. Well, how do the scores along the y-axis vary with respect to the variability of the scores along the x-axis or the predictor variable data? Eventually, not in this particular unit, but when we extend correlation analysis to regression analysis, what we will then do is examine how close the scatter plot fits what's called the line of best fit or the regression line. And in doing so, we'll be able to examine how accurate a future prediction can be made based upon the present data. On this slide, what we're looking at here are two different scatter plots, and just as the term suggests, what we're doing here is examining how scattered the data are in describing the relationship between two variables. So as we indicated on the previous slide, here we see along the x-axis we have a range of data that we call the predictor variable. And along the y-axis on both of these plots, we now call the variable of interest the criterion variable. One way that we will eventually work towards with the regression analysis is that we will fit what's called a line of best fit or a regression line as a descriptor of how the data plot between x and y. And so what we see here on the figure on the left, here we see again, this is just a subjective estimation here, but quite a bit of scatter. But even with this scatter here, we can see a general tendency that as the value of x increases from left to right, the value of the y variable increases from the bottom up to the top. but it's far from a perfect relationship. And so we'll calculate the statistic of a correlational analysis, which is the R value. And the R value for this relationship has been calculated to be 0.6. And that's used as an indication of how well the line describes these data. On the right-hand side, here we see a similar relationship between x and y, is that in that as x gets larger, y gets larger, but we see that the actual blue raw data points are clustered closer to this regression line as it was on the left hand side. And as the actual data are clustered closer to the line, the test statistic in this case will be a larger value. And here we see it's 0.9. The largest possible value, as we'll see here on the next slide, is actually 1.0. And so this slide shows two extremes in possible correlation coefficients. As we start on the left-hand side, once again we have our predictor variable along the x-axis and our outcome variable of interest, or what we now call the predictor variable, or I'm sorry, the criterion variable, along the y-axis. But here on the left-hand side, we don't see any clear discernible pattern in the data, in that as the value of x increases, there appears to be no clear pattern along the y-axis. And so a line of best fit in this scenario would likely be a horizontal line or a near horizontal line. And in this situation, the R value is just simply 0 in this extreme case, and being a relationship of 0, or an R value of 0, indicates no relationship between X and Y. The other extreme here, which is rarely found in actual research, but this points to the fact that as the raw data in the blue dots, which you can hardly see right now, do not have any separation from the line of best fit, that would yield a perfect correlation, so that each value along x as x increases in perfect proportion along the y-axis. One last point about relationships here. Here we see two examples from the textbook, and I'll start with the left-hand side. Here we see a relationship between room temperature and rated comfort of people staying in that room. And so we see all these blue dots, and we see quite a bit of scatter if we use a straight line in the green here. And so the straight line, based upon the scatter, would generate a correlation statistic of 0.3. Not a very strong correlation here. But if we take a look at the blue, as x increases from left to right, we see that there's an increase in related comfort where it peaks, and then it starts to decrease again. And in this situation, a nonlinear curve in this situation would actually yield a larger R value. And so, depending upon the nature of the two variables, researchers may opt to use a line of best fit, a straight line, or some sort of nonlinear function to best describe the relationship between room temperature and rated comfort. On the right hand side here we see a typical correlation analysis where we have the line of best fit with a calculated R value that's quite a bit better, has a larger strength than the one on the left hand side at 0.76. But examining these blue dots, we clearly see that there is some sort of pattern that emerges as high school GPA increases. The results on a driver knowledge test also increases, but the blue dots appear to plateau past a certain high school GPA, that individuals that score higher on a GPA don't necessarily score that much higher on a driver knowledge test. So in a situation like this, once again, as the left-hand side, a nonlinear function would be a better approximation of the relationship between high school GPA and driver knowledge test than a straight line. Therefore, when examining the relationship between two variables before diving into the actual mathematics and statistical calculations, generating a scatter plot will give the researcher an intuitive sense of a pattern that emerges between the two variables of interest. So this ends this initial lecture on simple correlation analysis.